Before we look at Cilium's architecture, let's understand what it is and why we use it. In Kubernetes, every pod needs to talk to other pods and services. This is handled by something called a CNI or Container Network Interface. It's basically the system that connects all containers together so they can communicate. Older CNIs like Flannel or Calico worked fine for basic networking, but as clusters grew larger and more complex, we needed better security, visibility, and performance. That's where Cilium comes in. Cilium is a CNI plugin that uses a technology called eBPF. This allows it to run programs directly inside the Linux kernel, so it can handle traffic faster, apply security rules efficiently, and even monitor network flows in real time. This diagram shows how Cilium works internally using a layered architecture. At the top, we have the Cilium layer, which interacts with orchestration systems like Kubernetes. Here, you can see components like the Cilium CLI, policy repository, plugins, and the Cilium monitor. All of these help manage configuration, policies, and observability. At the center, the Cilium daemon runs per node is responsible for translating all these configurations and policies into eBPF bytecode, small programs that can safely run inside the Linux kernel. At the bottom, we have the kernel layer. Here, the eBPF programs are injected into the kernel and attached to network interfaces like ETH0 and containers. These programs manage traffic routing, enforce security rules, and collect observability data directly inside the kernel, which improves performance and reduces overhead. So overall, the slide shows how Cilium connects orchestration and monitoring tools at the top with efficient kernel-level networking at the bottom using eBPF. Now, let's discuss all the components in brief. The Cilium agent runs as a daemon set, meaning there's one agent pod on every Kubernetes node. It's responsible for most of the heavy lifting in Cilium. The agent talks to the Kubernetes API server to stay updated on pods, services, and policies. It writes eBPF programs into the Linux kernel, handling L3/L4 networking, security, and observability. For Layer 7 application layer traffic, Cilium uses Envoy proxy for routing and inspection. The agent also communicates with the CNI plugin to detect when new pods are created. It can spin up DNS and Envoy proxies on demand when network policies require it. When Hubble is enabled, the agent starts Hubble gRPC services to collect flow and telemetry data. In short, the Cilium agent is the core component running on each node, managing eBPF, syncing with Kubernetes, and enabling secure and observable networking for all pods. Alright, so we know the Cilium agent is the core component on each node. Now, let's break down some specialized team working inside that agent pod. At the very heart of it all is the agent process. Think of this as the brain of the operation. It's constantly watching Kubernetes for instructions and then translates those high-level network policies into the eBPF programs that the Linux kernel uses to manage traffic. Next up is the Cilium CNI plugin. When a new pod is created, this plugin is the first on the scene. It acts like a network plumber. It talks to the agent process to get the pod and IP address and connects it to the Cilium network, ensuring all the security rules are applied right from the start. Then we have the Cilium client. This is a small diagnostic tool built right into the pod. You won't use it every day, but it's incredibly useful for troubleshooting. It lets you talk directly to the agent process to inspect what's happening under the hood, like checking active policies or connections on that specific node. And finally, we have the embedded Hubble server. This is the agent's eyes and ears. It collects all the rich network flow data directly from eBPF. This is what powers the Hubble UI, giving you that amazing real-time visibility into which services are communicating without adding any performance overhead. So to sum it up, the agent process is the brain, the CNI plugin connects the pods, the client lets you investigate, and Hubble gives you visibility. Together, they form the powerful core of Cilium on every node. Okay, so we know each Cilium agent has its own embedded Hubble server, giving us a local view of network traffic. But in a real cluster with many nodes, How do you get a single unified picture of everything? That's the job of Hubble Relay. Think of the relay as a central aggregator. It's a separate deployment that automatically discovers all the Hubble enabled Cilium agents in your cluster. It then collects all their individual network flow data and combines it into one powerful cluster wide stream. Now, how do you actually see this unified data? You have two primary tools, the Hubble CLI and the Hubble UI. The Hubble CLI is your command line tool. It connects to the relay and lets you query network flows right from your terminal. It's perfect for quick checks, troubleshooting, or even scripting. And for a more visual approach, you have the Hubble UI. This is a graphical dashboard that also uses the relay's data to build those famous service maps. You can visually trace requests, see dependencies, and watch your cluster's network activity in real time. So, in short, the relay gathers all the data into one place, and the CLI and UI are the powerful tools you use to see and understand it. So far, we've talked about the Cilium agent, which runs on every single node, but some jobs only need to be done once for the entire cluster. That's where the Cilium operator comes in. Think of the operator as the central coordinator or manager for the whole cluster. While the agents are the busy workers on each node, the operator handles the high-level cluster-wide tasks. This could include things like managing IP address allocation across all nodes or coordinating identities. As you can see in the diagram, the operator communicates with the agent to give them the cluster level information they need to do their jobs. But here's the most important part. The operator is not in the critical path for network traffic. This means if the operator temporarily goes down, maybe for an upgrade or a restart, your cluster's networking keeps running just fine. The agents on each node already have the rules they need to continue forwarding and securing traffic without interruption. So, in short, the Cilium operator is the resilient central manager for cluster-wide tasks working behind the scenes to keep everything coordinated. Now, what about this purple icon representing Envoy? This is an optional but powerful component that Cilium uses for Layer 7 security. When you need to enforce policies on application traffic like HTTP or gRPC, the Cilium agent uses an Envoy proxy to inspect the data and apply the rules. It's how Cilium extends its powerful security all the way up to the application layer. And that completes our tour of the core Cilium and Hubble components. We've seen how the agent on each node, the central operator, and the Hubble observability layer all work together to make our network secure, observable, and fast. I hope you now have a clear picture of the architecture behind the magic. In our next session, we're going to move from theory to practice with a hands-on demo. We'll walk through the process of installing Cilium on an AWS EKS cluster, and we'll be doing it in a very interesting way, using chaining mode. This will show us how we can layer Cilium's powerful features on top of the existing cloud network. At IMESH, we provide enterprise-grade support for Cilium CNI, helping you deploy, operate, and troubleshoot Cilium in production with confidence. Thank you for watching, and don't forget to subscribe for more insights on open source networking and Kubernetes technologies.